Um, Hi everyone. Um, I'm Johan Cook. Sorry, I just want to get confirmation from Jackie. Should I start? Seems so. I'm Johan Cook, co-founder of SeeBlocks. Um, so we invented a product. I'm going to switch over to the slideshow, and then we can take it from there. Okay. We invented to help schools and teachers teach the subject of electronic technology, digital technology, and electrical technology, and especially help them with the practical part of it. We call it the SeeBlocks. It's individual blocks that you build onto a baseboard, as simple as you would build a puzzle basically. But as you build the circuit, as you can see here in the right hand image, you build the actual schematic diagram of the circuit, but it's also a working circuit because at the bottom of each block is the actual component. Electronics is difficult, and that's why many schools avoid it. And we want to make that easier and reduce that barrier because there is a big need for students of electronics. It makes it as easy as building a puzzle, and for beginners it, it offers a big advantage, a lot easier than breadboards. And our LMS also, we have an LMS, and I'll get to that later on, with content to guide the student through, but it's optional and it requires no prior knowledge of electronics, and it can work on any smartphone or computer. So I'm going to jump right in and show you a demo of how a typical circuit sorry, is built on the SeeBlocks. This is one of the early experiments where the learner have to build a circuit and measure the current that flows through the LED and the resistor. I'm connecting the battery, and then the circuit is not yet complete. That's when you connect the multimeter. The SeeBlocks also don't require anything else than the kits itself. You can use your own multimeter. For some experiments, you don't need a multimeter. And there we get a reading. I'm breaking the circuit there, and then I'm closing it again, just to show you that it's actually working. Just on a side note, while I'm doing this, I cannot see any questions because my presentation takes both screens. So, but I will, if there's any questions, I will get to them. And some of you might think, okay, that was a very simple circuit. Is that the best you can do with SeeBlocks? No, it's not. It's got this expandable baseboards, and you can just add more and more of them to each other and build this circuit as complex as you want. Here we have a light sensor with the LDR and a touchpad here at the bottom. And if you hover your finger over the light sensor, the LED goes on and off, or if you touch the button. And this is with a transistor amplifier and so on, so you can go more complex. Our LMS, let me just pause here and see if there's any questions for me. Okay, doesn't seem to be. Brochure for prices. Okay, someone asked brochure for prices. I will send that afterwards. We'll make it available to everyone who wants it. Okay. The SeeBlocks is coupled to a optional learner management system with content that covers the whole grade 10 electronic technology and digital technology and electrical technology. Um, so this is basically to help students to study on their own. It's got a lot of explainer videos and so on. It's 100% CAPS aligned. It integrates the theoretical part with practical experimentation in a way that's not always possible in the classroom, because the learner can learn the theory and immediately do a practical experiment after that. And it's rich with explainer videos, text, images, fun facts along the way, and then experiments and quizzes to test the learner's knowledge. Okay, so at this point, I'm going to demo the LMS. This is the home page. Here's the list of courses available. Getting started is, like the name says, getting started, learn how to build circuits, how to use a multimeter, take measurements, EE fundamentals, power and energy, circuit analysis and components, semiconductor fundamentals, digital fundamentals, electromagnetism, wireless communication fundamentals, and then a separate course with just the practicals to help teachers. And then there's also this free course that you get with every kit, and that is DIY circuits. So no theory is explained there. It is just a lot of circuits that learners can build to learn and play with electronics. Okay, so I'm going to jump first of all to the experiment we just saw to show you how the experiments are interwoven into the content. If I can find the place that I was looking for. Okay, experiments with current. There we go. So that video that I showed earlier on, in the content, this is where the student would have to build that circuit. And then I'm just going to jump to page 1. Sorry, wrong one. There we go. The learner has to build this circuit and then take a measurement and type in the value here and click on check. And if you get it right, you get a point and you can move on. So that's basically the format of how experiments are done. Let me show you a typical reading. Everyone knows resistor color coding. So here's our explanation of it. And fun facts. We have lots of fun facts in between our content too. So here's a fun fact of Michael Faraday and his results. So anywhere where you have some interesting thing to mention that's not part of the curriculum, we package it as a fun fact. And at this point, I'm going to ask Jackie to show us the video, because there's an issue with playing sound from my side, to show you how our video explainers look like. So I'm going to stop sharing here. Jackie, are you there?
What is voltage? Let's say you have a system consisting of 2 tanks connected by a tube. The upper of the 2 tanks we'll call the negative tank. This tank has a valve that controls water flow from the tank. In the center of the tube, there is a water wheel which we'll use to demonstrate work being performed later on. And finally, at the bottom of the tube is another tank called the positive tank. By now, I'm sure you're wondering what all of this water business has to do with voltage. Well, the water molecules in tank 1 has a higher potential to do work than those in tank 2, even when there is no water flowing between the tanks and thus no work being performed. It is this potential difference that can be utilized to do some work. So let's open that valve. Immediately, you can see the water molecules start flowing down between the tanks, and in the process, turning the water wheel. By allowing this flow of water, one is actually reducing the potential difference between the tanks by converting the potential difference in energy into real work being done by turning the wheel. If you have a battery specified at 1.5 volts, it means that there is a potential of 1.5 volts between the positive and negative terminals of the battery. If you connect the battery to a circuit that allows for the flow of electrons from the negative to the positive terminal, much like the water molecules between the tanks, you are also slowly lowering the potential difference or the voltage of the battery.
Okay, thank you. I saw in the comments people say my audio is very soft. That is, I just realized that's because the browser latched onto the wrong microphone. So what I'll do for now is I'll just speak a lot harder. Well, let me just try to switch the microphone to my head. Could someone tell me if they can still hear me, and is the audio better now? Okay, great. Thank you, HJ. Good. Let me continue with my presentation. Thanks for that, Jackie. To the LMS. So we've got quizzes. I've shown you the videos. We've got lots of those videos explaining different concepts. And then we test two aspects of the learner's understanding. First, we test their conceptual understanding of whatever they've learned, like voltage in this case. And then we test their understanding to apply the mathematics to it. So Ohm's law quiz. I'm going to go to the Ohm's law quiz and say continue the last attempt. So here you can see what our quizzes look like. In this case, I have to complete this VIR triangle. I think this is familiar with every person knowing the basics of electricity. And then we ask just some insight questions to test the students' understanding of the concept. And then, so that's the conceptual, and then there's the calculations quiz, where the learner must do calculations. In this case, calculate the resistance. I specifically typed in the wrong value there to just show you what it looks like. And then on the LMS front, lastly, is the reporting. So there's reporting for the student himself or herself. You can see there in the right-hand bar, there's all the different elements of this course. And in my case, I've completed all of them. And you can also go to grades. And here's an overview report of the student in question. In my case, this is the courses I've completed and the grades I got for them. And then also I can do a user report. Now, all of this is also available for the teachers, of course.
So here's all the different elements inside EE fundamentals and the different marks that I got for them and my course total. So yeah, that is in terms of the LMS. I have to add again, I mentioned this earlier also, the LMS completely optional. It's only if you want the learners to do this kind of content on their own. You as a teacher can just buy the SeeBlocks kits and use that as a practical assistance tool in the classroom. Okay, and we also have the LMS also has an app. And I'm not going to show the whole video, but you can just see from a clip of it, it works perfectly fine to do this content on a cell phone also. Applications is an assistant tool for the teacher to do the practicals, also to enable learners to catch up on their own, those who have fallen behind, and to enable them even to do practical experiments at home. The different products we offer is 3 different kits. And we also have some basic test equipment with a focus on low multimeter, a very low cost oscilloscope, and a low cost wave generator. And that is it from my side. I'm going to switch on my camera again. Stop sharing and camera on. Okay. Any questions? None so far. While we're waiting, Jackie, how do I share the brochure with pricing to everyone?
Would you like to share it on your screen, or would you like to email it out?
Will you give me an email list to distribute it?
Okay, I'll let them know. You can send it through to the organizer, and then they will distribute it from there. You have a question in the Q&A?
Jackie, I see your icon appear here, but I don't hear your voice. Are you speaking?
Yes, can you not hear me?
Okay, let me look. Yes, so the question is, can SeeBlocks do all simulations from grade 10 to 12? It can, definitely. We don't have LMS content for grades 11 and 12 at this point because it's optional and it's not necessary. But you can use the kits to do, yeah, any experiments from grade 10 to 12. The content on the LMS covers the whole of grade 10 at this point. Thank you, everyone, for your time. It seems like we have no more questions. Well, you still have my contact details as shown in the screen. It's easy, very info@seeblocks.education. Let me type it here as well. info@seeblocks.education. So drop me a mail if you have any further questions, and thank you very much for your time and the opportunity.